Okay, welcome to the next section. We are on page 52 of the textbook. This is the study guide for PYC 3704 by P. Kruger and H.C. Yannicka. It's a great study guide. And what we're going to do is we're going to just walk through it together. As you can see, I'm studying it along with you. And no, I don't have time to go back and do the recording 2 more times, so it sounds really good. We're just going to bumble along, and I hope it's helpful. Okay, so we're looking at normal curves here, normal distribution curves. And you will see that all of these can be quite different, but they all have a few things in common, okay? There are only two variables in all of them, and that is the mean and the standard deviation. So here's our mean, signified by the symbol mu, and here's our standard deviation, signified by the symbol sigma, okay? And you can see that this is for a population, not a sample, because we're using mu for our standard deviation instead of an S, and we're using, mu for our average, okay, instead of, oh my gosh, okay, and a sigma for the standard deviation instead of an S, okay. Right, so you can see I really am bumbling along. So there's a few things that, so as I was saying, the mean and the standard deviation are variables. So the mu can vary. It can be here, it can be here, it can be of a whole lot of different things. The standard deviation, sigma, can vary. It can be big, it can be small. Everything else in here is a constant, all right? Now, and that makes it incredibly useful for statistical analysis. Let's look at what all of these different normal curves have in common. They're bell-shaped. Most observations are closer to the mean. They are symmetrical. The left and the right are mirrors. They are continuous. So they're continuous in two ways. One is that this goes off to a theoretical infinity. And the other is that this is a continuum. In other words, there's no little holes in this line. These are real numbers with very, very, very fine, infinitely fine decimal points in them, okay? And they are asymptotic, which means that this line and this line never touch, but get closer and closer and closer towards infinity. Okay, now let's look at the z-scores, or the standard normal distribution. Okay. This is a normal distribution curve that has two particular qualities. Firstly, the mean is 0. Okay. And secondly, the so distracting. The mean is 0 and the standard deviation is 1. Okay. And that gives us a curve in which certain numbers are constants. These numbers here are constants. Okay, so one standard deviation from the mean is always going to have a score of 0.3413. And this side also 0.3413. Okay, so this is the standard normal distribution. Standard normal distribution. And indicated by the letter Z, z-scores, meaning this axis. This is the z-axis. So this is a z of 1, a z-score of 2, a z-score of 3. Okay. So the area underneath the standard normal curve can be calculated. This number is an area. This area goes to there, and of course this goes to infinity. And this goes to infinity. But when you add this whole thing up, it's always going to add up to 1. So this infinity is smaller and smaller and smaller and smaller and smaller. It's never going to go beyond 1. The total area of this curve is never going to go beyond 1. It's always going to add up to 1. Okay? And it's symmetrical. So half is to the left of this line in the average, and half is to the right. This is the average. Okay? So approximately 2/3 of the curve lies within one standard deviation of the 0. It's 0.68. If you add these two up together, you get 0.68. If you add all of these 4 together, you get 0.95 approximately. Okay? If you add 2 up, you get 4.477. And this is within 3 standard deviations of the norm, of the mean. Within 3 standard deviations of the mean is basically 99.8% of all the area. So only 0.002% of the area lies beyond 3 standard deviations of the mean. So that's effectively, for all intents and purposes, almost without significance. Okay. So there are some things to bear in mind. The difference between the probability that z is greater than 0 and the probability that z is greater than or equal to 0 is effectively so close that you can say that they are the same as 0.5. There are tables you can look up the standard deviation area on in Appendix D, okay? I'm not going to go there now, but you can scroll, you can flip over in your book to Appendix D and have a quick look at those tables. Okay. Area between standard deviation of -4 and +4 is statistically 1 because it's so close to 100%. Okay. So now there is a formula that we use. Okay, I'm actually going to, okay. Let's see, the formula is, it's called the Z transformation for hypothesis testing. So you can't transfer any variable that comes from a normal distribution to a standard normal distribution, provided you know the mean and the standard deviation of the variable scores. And the formula is Z equals X minus the mean over sigma, which means that Z equals whatever the number is that you're working with, X, the variable, minus the mean, whatever the average is, divided by sigma, okay? And then we can plug it into here. So let me just scroll over to page 55. There's our formula. Okay. X is the variable minus mu, the mean, over sigma, the standard deviation. So if we do this with a few simple examples, this is nice and easy. It's simple. Okay, so if we find a person has an IQ of 120 on an IQ test, and a standard deviation, the mean is always going to be 100 on an IQ test, standard deviation of 15 on normal distribution. Okay, so let's work that out. So the Z for them is 120, their IQ, minus 100, the mean, over 15, one standard deviation, is 20 over 15, which is 4 over 3, which is 1.333. So if we were to have it on the graph here, on the Z curve, the Z score would be 1.333. They would fall somewhere here, okay? Beyond the one standard deviation, they'd be about here somewhere. That's where their IQ would fall at 120, okay? Now, let's see. So so that would mean that they are brighter than 80% of the population or so, something like that, because this is approximately 68%, right? So I'm just guessing wildly, but you could work that out at the back of the book. Let's see. Standard deviation, standard normal distribution. If the Z score is 1.33, then that's like the top 10% of the population. That's very bright. Okay. For mathematical aptitude, this same individual gets 8 on a 9-point test for their aptitude in math, where the scale has a mean of 5 and a standard deviation of 1.5 on a normal distribution curve. Okay, here we go. So they get a score of 8, okay, and the mean is 5. So it's 8 minus 5 over the standard deviation. So that's 3 over 1.5, which is 2 standard deviations, which is super bright. That's like within the top 5% of the population. Because remember that 95% of people will fall in here. Okay. 95% of people will fall in here. There's 2 standard deviations. His mathematical intelligence is over here, and his general intelligence is over here. Very nice for him or her. All right. So where were we? Okay. We're really able to calculate the mean of a population of scores and the standard deviation of a population because we don't normally have population scores available. However, we can draw a representative sample of the population and use the statistics X bar. Yes, X bar is the average for a sample, and small s to calculate the Z score. Z would be the actual variable less X bar over standard deviation for a sample. Okay, here's another example just to help us get familiar with it. A student gets 56% for an exam and wants to know where they are in relation to the rest of the class. Suppose the mean mark for all the students is 52% and the standard deviation is 4. So that would be 56 minus 52. Okay, standard deviation is 4 over 4, 1. That person is within 1 standard deviation of the average, 1 standard deviation above the average. Okay. If we look up, I hope the average is not 52, it's a bit higher than that. Okay. Right. So it's actually quite simple. Now, the secret is to just do sums again and again and again and again and again. And what I do is I go to ChatGPT and I say, give me 5 simple problems for calculating the Z score. In fact, I'm going to stop doing this video and do that right now for myself because practice math like a language, you want to be familiar with it. Okay. Oh, here we go. Z score of 1 is within 0.68 of the mean, but relative to the whole population, It's actually 84%. The top, this person did better than 84% of the group. Okay, so as you get more and more and more familiar with this curve, it'll become more and more and more intuitive to be able to read it, which is an amazing ability to have, because you'll be able to look at it and know these numbers automatically, and that's incredibly useful. Here's one more, okay? Student got 56 for research methodology. The mean is 65% with a standard deviation of 6. So 65%, 56 minus 65 is minus 9. Over 6 is minus 1.5. This person is far lower than the average. 1.5 standard deviations below the average. Okay? Which is rather sad. So they did worse than 93.3% of the class. So if we look here, it will be here somewhere. And this would add up to 93.3 of that. Okay. Right. Here we go. Here's a picture. Okay, let's stop there and then continue in a short while.